In this video, I'm going to use the p-value method for a hypothesis test for a population mean when sigma is known. A tobacco company advertised that its best-selling non-filtered cigarettes contain at most 40 milligrams of nicotine. A consumer advocate magazine ran tests of 10 randomly selected cigarettes and found that the mean nicotine content was 43.3 milligram. The magazine editor believes that the mean nicotine content is greater than 40 milligrams. Using a level of 0.01, test the editor's claim. Assume that nicotine content is normally distributed and that sigma, the population standard deviation, is 3.8. So in this situation, the conditions are met to use the z-test, the test using the normal distribution. The sample size is 10, to summarize. From the sample of 10, the sample mean was 43.3 milligram, and the assumed population standard deviation is 3.8. Now, when we have a small sample size like this and we're testing a claim about the mean, we need to be told that the distribution is normally distributed. And in this situation, since we're told the population standard deviation, the conditions are met to use the z-distribution. The standardized test statistic for this problem is x bar, the sample mean, minus the claimed mean from the hypotheses, over the assumed population standard deviation over the square root of the sample size. So we do need to set up the null and the alternative. We need to identify the claim as a mathematical statement in terms of mu and structure the null and the alternative around that. It says here that the magazine editor believes that the mean nicotine content is actually greater than 40 milligrams. So as a mathematical statement, that's going to be mu greater than 40. Because this does not contain the case of equality, this makes this the alternative. So this is the editor's claim. And the current text I'm using has the strict case of equality in the null. Now, the manufacturer's claim, or what the manufacturer is advertising, is that their cigarettes contain at most 40 milligrams of nicotine. So actually their claim is that mu is less than or equal to 40. But we're doing this hypothesis test from the approach of the magazine editor. So what we have here is we have an upper tail test. And if we were using the critical value method, we would be shading a right tail area of rejection. But in this video, I want to use the p-value method. To use the p-value method, I need to find the standardized test statistic. So inputting into the formula, all of the pieces given in the problem, using parentheses around the numerator expression and the denominator expression. Although I could have done that numerator subtraction in my head. I get a standardized test statistic of 2.746. And the p-value method means that we need to find the area of extremity with respect to the standardized test statistic. The p-value is the probability of getting a test statistic at least as extreme as the one obtained from the sample. So in this problem, we have an upper tailed test or a right tailed test. So sketching the standard normal distribution and placing my p-value, placing my test statistic along the horizontal axis, the p-value is going to be the area further to the right. Because being further to the right, coupled with the fact this is a right-tailed test, indicates the area of extremity. So this area will be our p-value. Okay, because we have an upper tail test, we don't need to divide alpha in half, so we do not need to double that p-value. Because the p-value is a probability, in probability notation, this is the probability we get a z-score greater than 2.746. Okay, because this test statistic is 2.746. I can use my standard normal table, or I can use the normal CDF function in the calculator. When you are given a z-score first, and you're using the TI-84, you want to use the normal distribution, the normal CDF. So going to my distribution menu, I don't know why that's so bright. Okay, that doesn't help. Selecting option 2, the normal CDF, my lower bound, looking at the area that I'm concerned with, the lower bound is 2.746. My upper bound is positive infinity, so putting in a 1 with a bunch of zeros. Keeping it as standard normal. I'll get an area of about 0.003. So this indicates to me that it was highly unlikely to observe the standardized test statistic by chance alone. Using the p-value method, we want to compare that area or that probability to our level of significance given in the problem. So the p-value is 0.003. My level of significance was 0.01. This p-value is less than my level of significance. Now some textbooks or websites use the case of equality here. If your p-value is less than or equal to alpha, you reject the null. The current textbook I'm using uses p-value less than alpha. We reject the null. The case of equality is a bit arbitrary. Alright, so my decision is to reject the null. And going back to my null and my alternative, if I'm rejecting the null, I am in support of the editor's claim. In other words, there is enough evidence to support this alternative statement. So to write the decision and conclusion, the correct way to say it is that there is sufficient evidence to support the editor's claim, okay, that the mean nicotine content of the cigarettes is actually more than 40 milligrams. Now, thinking back to the perspective of the manufacturer, they are advertising that their cigarettes contain at most 40 milligrams of content. Based on the sample size of 10, what the manufacturer is advertising is not supported. We can get the p-value directly from the TI-84. If we go to our stat menu, over to tests, the first option is our z-test, and we have the summary statistics putting in the hypothesized value, the assumed population standard deviation, the observed sample mean, our sample size, and then changing the direction of the alternative. We'll get our standardized test statistic, which is very close to the one that I got finding it by hand. And here's the corresponding p-value. So you can get the standardized test statistic and the p-value from the TI-84 directly. You just need to make sure you put in the correct alternative